It's a pleasure today to welcome Diego Panici. Diego is a lecturer in hydraulical and water quality modelling and a civil and environmental engineer at the University of Exeter. He specialises in hydraulics and hydrology, especially with applications to riverine processes to investigate the effects on river geomorphology, infrastructure and water resources. Diego completed his PhD at the University of Southampton, which investigated the accumulation of large woody debris at bridge piers and developed a methodology to estimate the size and shape that can be expected for given flow and large wood characteristics. His postdoctoral fellowship looked at estimation of scour risk at bridge piers with accumulated wood. It also looked at landslide channel connectivity, multi-phase modelling, flood impact on strategic networks with climate projections, adapting water abstraction from rivers under increasing dry conditions. Since 2022, Diego has been a lecturer at the Centre for Resilience in Environment, Water and Waste, where he started working on hydro-environmental restoration and natural flood management. It's great to have you here today, Diego. I'll pass over to you and we'll take questions at the end. Thank you.
Thanks, Hannah. Thank you so much. I'm just going to show you the chat Padlet for today for discussions. So feel free to open it, comment on anything, or feel free to wait until the end of the presentation. And I'm going to now share the presentation with you all. I hope you can all see it properly.
Yeah, we can. Thank you.
Thank you so much. So welcome, everyone. It's a real pleasure for me to be here today. As Anna said, my name is Diego Panici, and I'm a lecturer at the University of Exeter. My topic today is the long journey of instream large wood from debris to resource, which is effectively kind of a description of my academic career so far. So it will be a sort of personal journey as well as part of this. Here's the link to the Padlet with a QR code in case you are interested in using your phone. A little bit of background about myself. So this is me. As I said, I'm a lecturer. I'm originally from Italy, and I received my BSc and MSc in Civil and Environmental Engineering in Rome, in which I worked mostly on water resources, flood modeling, all the kind of hydraulic engineering syllabus. Then I worked for a while with the university as a research civil engineering, in which I started having some exposure to physical modeling, like using Flume, or numerical modeling using complex models, 3D, 2D, etc. After that, I worked as a while for civil supervisor, so I had this experience in the construction industry for a big motorway project, and then I went back into academia, where I did my PhD at the University of Southampton, as my topic was accumulation of large wood at bridge piers, and then moved to Exeter for a postdoc, and then became a lecturer. And the university still had the old logo that's very different from what we have today. But what I want to talk about today is large wood in rivers. And just to put that forward, there will be a little bit of interaction available in the form of word clouds, etc. And the first one is, I will be really keen for you if you can log on to, oh, sorry, I need to log in myself. I'm actually logged in, so I need to stop sharing and share in another way, otherwise it wouldn't work. Sorry about that. And yeah, that's better. So I would be really keen for you if you could get onto menti.com and use this code up here and comment on what you think about, if I say large wood in rivers, what is that is coming to your mind first? So what is that you think large wood is in river? And it would be nice if everybody can give some ideas for that. And I'm just going to wait 1 or 2 minutes for it. Yeah, that's great. That's looking fantastic. Yeah, that's all looking lovely. I can see already some very interesting words in there. Diversity, yeah, that's a really good one. Habitat dam, tree trunks, blockage, habitat, logjam. So all of these are absolutely true. Cannot agree any more with you. And I like to see the habitat there is a big one, because something that is particularly interesting, and we'll discuss further in this. So yeah, all of these are very much true. And some of you have written about fallen debris, blockage. So this is something that maybe in the geomorphology world we don't look much at, but when you go out and you particularly think about bridge owners or even the general public, might be the first thing that springs to mind. So large wooden rivers, it does actually constitute a hazard, because what we have is that it will exert actions to structures, it will increase the flood risk, and there will be some impasse, so impact forces, and all other similar effects that obviously constitute a hazard. That means there's quite a complex system of things that appears. So we have damage to infrastructure, we have flood risk, maintenance and removal, and also there's this complex management aspect, because not everybody is actually aware that there's many different responsible entities and people that are responsible for large wood. So sometimes it can even be really confusing and creates very difficult management. For maintenance and removal in general, that's quite a key issue, because there's high costs for tree removal works, often requires road closures, heavy machineries. So it's not an easy job to do. And many times you have damage to piers. Like if you see on the top right figure, that's from Austin's Bridge in Devon 3-4 years ago during a storm, and that the impact from large wood damaged the pier. So there's a cost related to that. And we have flood risk. That's perhaps quite an easy one to spot, because we have a blockage to bridge openings, meaning that we reduce the available flow area, and therefore we have that the increase on the backwater will be quite significant. And especially in large river, the effects could be extended for several miles. So it's quite an important factor. But I guess one of the few aspects that really has a substantial impact is when we have damage to the infrastructure. Because what happens in this case is that the undermining of the bridge foundations can cause bridge failure. And we have seen it many times, but when there's woody debris, although we will see shortly that this word should be dropped, it may significantly contribute to bridge failure. Because what we have is that there's an increase in the erosion at the base of the pier. There's therefore pier undermining, and therefore that means that the design load that the bridge was meant to be carrying can no longer be carried. But we also have additional lateral forces that they can displace the pier. So another one for you, a very quick one. How many bridge failures are caused by large wood? Do you think 10%, 20%, 30%, 40%, or 50%? This is just to see if you think how important large wood will be in terms of bridge failures. And I'll have an answer for that very shortly. Right, so there seems to be some consensus about 20% or 10%. 50%, that's very brave of saying that, but I can already tell you that is not the case. The actual answer is 30%. So roughly 1 in 3 bridge failures has been caused by large wood. So you can see it's a very important aspect in terms of hazard to bridges. And the other question that you may ask is that, well, how frequently does large wood accumulations occur at bridges? Turns out it's actually quite frequent. This is a map of Devon. This is the work we have been doing in 2020. It was to estimate how many bridges had some history of large wood accumulations. And the majority of the bridges on the main rivers did have some history. So we had on the Exe, on the Torridge, on the Tor, on the Tamar, on the Dart. So all of the major rivers in Devon did have this kind of experience. What we found out is that actually it is possible to have a direct evidence of history of accumulation. But the other information that we can infer is that also if we have repeated history, then there's a highly likelihood that these bridges are really likely to liable to accumulation. So it may happen again in the future. You have two examples here. The one on the right-hand side is from the northeast of Italy. There's just a Google Earth photo, and that is a railway bridge. I used to actually commute on the bridge, and I remember seeing those large wood accumulation regularly. And if you go on Google Maps and you start browsing all the historical photos, you will see that it occurs quite regularly. On the left-hand side, we actually have an example from Devon that's on the river Torridge. Although the accumulations are smaller than the one on the right-hand side, they still occur quite regularly. And Devon County Council pay quite a hefty amount of money every year to remove the large wood accumulated at these bridges. So you can see it's quite an important topic in terms of bridge hazard and bridge maintenance. And then we got the other method that we identified as indirect evidence. This is essentially a situation in which we know that there's presence of large wood. For example, a bridge upstream of another bridge has some history, but the bridge downstream doesn't have any history. So we can say that there's a potential likelihood that that bridge will be subject to accumulations as well. But if you remember this slide that I showed you just a second ago, the majority of them, they do have a history of accumulated large wood. So it is actually possible to estimate that directly. That brings me to the next step, which is, okay, how do we define the hydrodynamic actions to the structures? So this is scour. For those of you who are not familiar with scour, this is the erosion at the base of structural element. In this case, could be a pier. And what happens with normal flow without large wood? There will be a scour hole, the formation of the scour hole around it. But when you add large wood accumulated, then you can have that the increase can even double the depth of scour, meaning that if you are a bridge engineer and you are designing your bridge with a certain foundation depth, that might not be accounted for the effect of large wood. And as we said earlier, there's 30% of bridge failures that are actually due to large wood accumulations. But there's also a few other things to consider. So crucially, the size of scour depth depends on how much blockage do we have. So how much of this large wood accumulated at the bridge pier will have. So it depends effectively on the area that is blocked by large wood. It also depends on the relative water depth, so the depth underneath the large wood jam, and depends on how much it extends upstream. So the first key question was, how do we determine the size of large wood accumulations? Well, as part of my PhD, I carried out 732 laboratory experiments in a flume, which was quite a lot, I must say. And all of them displayed the similar trends, similar patterns, which are quite crucial now to understand why we have these behaviors. So all of them resemble the half-cone shape. So all of them, they had the same shape for all different conditions that were studied. But also, quite crucially, all the accumulations failed when they reached the maximum size. So they grow until they get to a size and they start to rotate about the pier and they detach. And that's the end of it. Quite interestingly, also, the uncertainty in estimation of that, so the maximum size that can be achieved, is actually rather small. You can see in this figure on the right-hand side, they represent the dimensionless width, height, and length. And they all tend to be in this narrow band. So it does suggest that if we have accumulation of large wood and there's potential for large wood to accumulate until the very maximum size, that will be within the narrow band that we can observe there. And so we developed some equations in which it is actually possible nowadays to estimate the maximum size that a large wood accumulation can reach to a bridge. And this was part of my postdoc when I was here in Exeter, we can actually try to include that also in the scour estimation, because we have equations to estimate scour that are based on plenty of experiments from the past, but few of them actually try to investigate large wood. So we try to do the same. And what we found out is that while we can actually, instead of redoing the equations entirely, we can just include an additional factor, that FLW, in which we account for the increase in the scour depth that will be due to large wood. And in that case, it just boils down to knowing the size of large wood accumulation. So based on a series of experiments that we carried out, we're able to determine that F debris. And based on that, we have 3 different factors that depend on the size and the blockage area that can determine how much it can increase. So just as a reinforcement statement here, the accumulation size is a critical quantity. So we do need to know the accumulation size to effectively estimate what will be the effects of scour. Just to share that the results that we had from our research, they have been included now in 2 manuals. The one is the Syria SP171, which has been published in 2021, which includes several of the publications that we got out of it. So today it's possible if you want to use those equations to actually try to estimate the scour depth, but the same also for national highways. So that's the CS469, which is a standard, which is used for bridges in highways. And there is now a new section, which is compulsory for use, which gives you the estimation of large wood and the estimation of scour due to large wood. So it's quite interesting that all of this research that we carried out is now embedded within the standards for highways. So any bridge engineer will have to use these equations. Right, so that was an overview on how we interpret large wood as a hazard. But of course, it's not just the end of the story, and actually, this is just a small story in comparison to what large wood in rivers actually is. It is a resource, because we are the ones that are effectively creating the hazard by putting structures into rivers, but large wood is a natural resource. And nowadays, we started realizing that actually, if we start using large wood for river restoration, natural flood management, or riverbank protections, it's an amazingly powerful resource. So that's why you probably see over my presentation that large wood should not be referred to as debris when using restoration, or we should avoid to call it debris at all. So we should always call it large wood because, yes, it's got an hazard component, but most importantly, it's a resource. And therefore, this brings me to the second part here, of how we interpret large wood in river restoration. So I would like to, oh, where's my cursor gone? Sorry, I lost my cursor. Right, so if you could look at the speaker and again, try on Menti. So this is a normal landscape that we would expect around the UK or around Europe, if anything. Can you tell me if there's anything wrong with it? Or if you can see that there's something wrong and that you can include it there? Because, yeah, there is quite a bit that is wrong with it. So I will leave that to you for a minute and then can discuss that. Very nice. Oh, sorry. Some very nice and interesting answers. My Teams is going mad. Sorry, I'll just use this one instead. Yeah. Oh, I like those. Yeah. Yeah, they're very good answers. Well done, everybody. That's fantastic. So straightened lack of trees, straight river engineered banks, channelization. Wow, you're on fire, really, because all of this resonates a lot. Nutrient pollution, yeah, great one there. Development, hardly any trees, yeah. And that's also another ongoing issue for our landscapes, because we know that we do lack trees in our country. Yeah, that's amazing answers. Thank you, everyone. These are really encouraging. So let's have a quick look around. Sorry that I flip from one to the other, but Teams doesn't seem too happy. So first, well, impermeable surfaces. So we got a town, meaning that we're going to have a lot of impermeable surfaces, quick draining into river system, high risk of flood, increased sewage spills into rivers. So all sorts of nasty stuff that we really don't like. And we do know that are a problem that is actually increasing instead of decreasing. Well, developments on floodplains. So we have human activities on areas that are near the river and that we have very high flood risk, because, well, floodplains are quite flat, easy to build. We need new houses, etc., etc. Where do we build? In areas that then we have the flood risk is quite high. And this one came out quite strongly, and I'm very proud for all of you, because, yeah, this is quite a crucial problem. Canalization, so straightening, raising of the banks, disconnection with the floodplains. That's a huge problem that we are experiencing. It's so detrimental for aquatic habitat. Then we have water abstractions. So that was meant to be a reservoir in the drawing. I know it's not totally clear, but it's used to supply drinking water. However, we have serious issues of over-abstraction. We have dry out, loss of habitat, drop of water table. So again, all sorts of bad stuff. And then we got industry and agriculture. And whilst obviously we need that in our society, well, they are quite nasty for pollution. So we have farming, industrial, agrochemicals. They have highly detrimental effects on water quality and biodiversity. So you can see that we are really doing a lot of bad things to our landscape. So that's why this is another example. You may recognize this. This is the real Y Simmons yacht. Beautiful, very spectacular if you go there. And it looks quite, you know, an extremely peaceful landscape. However, this is what happens there. So we have the River Wye is becoming a dead river. So one of the most beautiful rivers in Britain is being treated and like this, and is literally, as the Guardian said on the bottom there, is suffocating to death. It's not like it's a problem that is from yesterday. It's been going on for years. So we do know that this is a key issue that we need to consider. And if you look at this picture, even more depressing, sadly, is that from the Rivers Trust report earlier this year, we know that there's no river in the UK that are in good overall stages. This is such a depressing news, sadly. And we can see that 85% of the river stretches, they fall below good ecological standards. So that's extremely concerning. And then if we want some other very scary facts, is that wetlands have declined by 75% in the last century, freshwater vertebrate population by 83%. So this is an ecocide. We have the 1 in 3 freshwater species is at risk of extinction. So we're really facing a huge problem ahead of us. And there's many problems, and we saw them earlier, but one of them, which is quite crucial, is flow regulation. For example, where we have channelization, because this creates habitat fragmentation. We remove potential habitat for fish and invertebrates. So there's a disconnection between the channel and the floodplain, meaning that all potential habitat area is completely removed, and then there's channel instability. So you can see that flow regulation, while is commonly thought as to be a positive thing, in reality creates a lot of negative results. That's why river restoration comes into play. So river restoration has got basically three main targets, which is to recreate habitat diversity, increase the connectivity and continuity of watercourses, so create a whole big environment and habitat, and to reduce the spread of pollutants and contaminants. So what it's effectively trying to do is to change the hydraulic and hydrological functioning of a river system so that natural processes can be restored and replicated. Also, quite importantly, don't forget that we need to create new flow patterns and fluvial landforms for habitat creation, because that's essential. Whereas if we have a channelized, incised river, that is not happening, and that is detrimental for aquatic life. Also, we need to increase the channel roughness to increase mixing and reduction in flow velocity, so that creates spawning areas and rest areas for wildlife, and, well, of course, improving the water quality. And this is just to give you an example of a river restoration that happens in the River Ter in Switzerland. You can see on the left-hand side, the river before the interventions, there was a single channel, very fast flowing. You can see from the color of the water that it's pretty much uniform, so you cannot expect much variability within the channel. Then when you start adding a few elements, like what happens on the right-hand side, then you have that the channel starts forming broad, interconnecting, slow-flowing watercourses with variety of the flow. And this is extremely beneficial for wildlife. So we do need to go back to that kind of situation. And that brings me then to the question, why largewood? Yeah, we talked about river restoration, but why largewood? And as I say, try to abandon the main woody debris. So it does tick all the boxes that we say that are needed for river restoration. So hydraulic variability. So having largewood in river would change the hydraulic around the largewood, but also on a larger scale gives more variety. Then we have that the roughness is increased in the area surrounding the largewood and creates a gradient of roughness from areas non-affected and areas affected, meaning that it encourages creation of habitats. But we also have fluvial landforms that are highly varied when we have largewood. That's an example on the right-hand side from a restoration in Australia with the placement of largewood. You can see that even just a small intervention creates such diversity in terms of fluvial landforms that is essential. And then there's the possibility that having largewood would actually improve water quality overall. The various types of largewood used in restoration can be many. Just to give you a quick overview of the most used ones. So log jams are quite a classic. They create complex features and they favor pools, reservoirs, creation of vortices, so recirculation areas. So that's this nice connection between geomorphology and hydraulics here. They help to stabilize the channel. Sometimes rocks and other supports are used to do that possible. Then there's fleckers. They're fairly common in the UK. They are similar to log jams in terms of the effects that they produce, but they're on a smaller scale. And then there's tallwood or brushes, as they're called in other areas. They basically try to stabilize riverbanks and to slow water velocity. So they do also have this kind of effect. But one that I'm particularly fond of and has been making the news recently is called Stage 0. So this is quite a relatively new concept, but what does that really mean, Stage 0? So Stage 0 is a new concept. It's aiming to bring back a river prior to the Anthropocene, so prior of us humans has changed in the landscape. Effectively, what Stage 0 tries to achieve is to create a multi-thread, shallow, low-banked, all connected channel branches within the floodplain. And you can see on the right-hand side, that's a very interesting example. Over the centuries, it was possible to track the Danube in the Austrian marshlands. And you can see that in the 1700s, it was effectively what we just say. So a lot of branches, interconnected rivers. So what we would expect from a natural functioning river. Then over the centuries, for land reclamation, agriculture, etc., it became just a straightened, channelized river, meaning that all of that biodiversity, all of that potential for habitat creation has been lost. So the stage 0 is trying to go back to the 1700 situation, or ideally even before that, because we know that in the UK, it already started the process to channelize here. So we want to go back to the stage in which the river is free to flow and the river is free to just go wherever you want. Normally stage 0s are thought as 2-stage. The first stage is lowering of the floodplain and infilling the channel. So instead of having an incised channel, we have a channel that is infilled and the floodplains are reconnected. So that's the first key stage. Then the next stage is the placement of large wood and tree planting across the floodplain, because that creates flow variety, creates some stability around that, and also create different landforms so that there is this variability in terms of flow and habitat. And as a site which is extremely interesting here in the UK, which is Hollywood Estate, which is in Exmoor. This is owned by the National Trust, and a year and a half ago, they decided to trial the stage 0 for this river, on the River Allen. This was 2022, and that's some drawn footage by my colleague Alan Patrick. You can see this is essentially the channel. The channel was straight, no variation. This is the DM, reconstructed DM, and apart from the canopies, is very much what you could expect from the majority of river channels in the UK. However, this post-intervention in 2023, what they've been doing here is effectively what we say is the 2 stages. So first, they infill the channel and they lower the floodplain so that the channel could flow freely onto the floodplain. But also, they installed a huge amount of large wood all over the place, creating a much more varied channel and floodplain. And you can already see here from this picture that now the area which contains water is much more extended than it was before. So wetland recreation in itself has been huge when you consider this. And I'm going to now show you this video because this is extremely interesting. This is how the stage 0 looks like. It was taken a few months ago. So you can see this is what they call it, a beautiful mess, because there's no order, there's a lot of complexity, but at the same time, there's so much variation that is going on. You can see that the flow is very shallow. You can see that there's a lot of fluvial landforms that are formed. You can see that the flow varies quite a lot. So there's areas in which it's faster and areas in which it's slower, and there's more shallow or deeper areas of the flow. So it's effectively taking all the boxes of what a river should look like when it's fully restored. So another last minute, and I swear this is the last one. Now, in the footage that you just show photos that they posted earlier, what were, in your opinion, the most striking features? So what did really catch your eye and you thought, wow, this is really cool? Gravity and flow diversity, yeah, that's absolutely mesmerizing. A lot of wood, yeah. Oh, really good answers. Visible pool and riffle sequence, yeah. Wood mess, yeah, I called it beautiful mess, but I like it as a concept. The shallow water, yeah. Much wider channel, yeah, amazing answers, thank you. Habitat diversity, flow paths, floodplain connection, wow, that's really a lot going on there. Yeah, thank you so much. These are really, really interesting answers, thank you. And they resonate entirely with me because this is exactly what I see. So I see all this diversity, all this change in geomorphic features, which is unheard of in the modern rivers, unless you go to some like very wild rivers, for example, Scotland. But this is something extremely unusual down here in the southwest. So yeah, I'm really pleased that you agree with me on the type of observation that we can see. Okay, and that is our current situation and what we know, what we're observing. But there's something that is still missing, which is rather important at this stage. So the first key question is, how do the different types of large wood systems affect the hydraulic and geomorphic processes differently? Because I showed you there's potential for many different applications. We can go from as simple as putting a log in the river to creating a total mess, a total beautiful mess. But what is the actual hydraulic and geomorphic characteristics? We don't know that yet. This is something that we're still trying to figure out. And then this brings me to the next question. Okay, what if we know what the hydraulic and geomorphic processes will be, but then what could be the optimal placement and configuration of this large wood in the different types of river and stream habitats? Because again, that's something we don't really know. And we have that there's quite a few restoration schemes now going on, but we don't really know which one works best. So this is something that we really need to understand. And then another important fact, we've seen restoration at the small scale, so site scale, reach scale, but what about catchment scale? We don't really know that yet. We don't know if we implement large wood, what would change at the catchment scale. Would it have an effect or will it not have an effect? So this is something that we really want to investigate. And then finally, how can large wood be integrated within river restoration design and monitoring? And all the conversations I had in the past is that whenever there's large wood included in restoration schemes, normally it's a bit of a random choice rather than being guided by guidelines or suggestions. But answering the questions above can actually inform what we see there. So what are the next steps then? So currently, I'm supervising a PhD researcher that is working on this through one of the NERC GW4 plus DTPs. So she's doing an excellent job in that, and we are monitoring some of the sites, including Holnicut, and we're planning to do some modeling on that. But one of the very biggest news recently is that we've been awarded a NERC Pushing the Frontiers grant. So I'm leading this as principal investigator together with the University of Edinburgh, which are our partner. And we start the 1st of October next year. And we're planning to do quite an extensive work, which would have fieldwork in the sites that are shown there. Numeric modeling, so we will try to replicate the hydraulics and, if possible, even the geomorphology of these sites. And then we want to use artificial intelligence to optimize the design of river restoration using large wood. So that for us is the final aim, is getting to a stage in which we have knowledge of the processes happening and we can try to advise and provide guidance on how to actually implement large wood in rivers. And a question for you that you can answer on the Padlet or just send me an email or later in the Q&A. Do you know any restoration site that is worth investigating? Please let us know, because we are, of course, very interested having this NERC project also to see what's happening outside of these areas that we have identified. So we're getting to the end of it. The conclusions. So in-stream large wood has historically been controversial, and we have seen that it does indeed include hazard, but it also has a huge restoration potential. The key hazard problem is the accumulation of bridge piers, and it's known to cause substantial damage. We saw that up to a third of bridge failures can be reflected on large wood. But we have now the means to identify the bridges at risk and potential consequences. So that means that if we know there are bridges at risk, we can also implement protection measures so that we don't have to remove large wood from rivers, as it's been done sadly in the last decades, but we can actually try to protect those bridges and focus more on the restoration and resource properties of large wood. River restoration then is necessary because we have substantial damage to our rivers, so we do need to act, and we need to do it urgently. And large wood is one of the best natural solutions for encouraging the habitat formation, and it's also a natural resource that we have freely available. So there are some key research questions that remain open, but it is our work for the next 4 years, and we're very keen to collaborate with any like-minded people on this. And that's the Padlet. Feel free to feed on it. I will leave it open for the next 2 weeks, so anyone can keep feeding on it, commenting. I would like really to see a nice and thriving conversation. And that's all from me, and thank you very much.
Thanks, Diego. That was a great presentation. I was really, surprised at the percentage of bridge failures that are caused by large wood. That I thought it'd be much less than that, actually. So thank you, and that was a really really nice to see that imagery of the Holnicott estate. And it'd be great to see the monitoring you've got going forward. What have you planned to monitor there?
So we're trying to do a sort of multi-scale, multi-nested monitoring. So we would do hydraulic and hydrological monitoring in situ. So we will monitor change of flow. We're trying to use large-scale PAV to get the change of flow, so that we'll have a measure of that. But we will also plan to use multispectral drones and multispectral imageries to capture the variation in geomorphic features. We also recently got a LiDAR drone, which is a new toy in our arsenal, and we're planning to use it for this purpose as well. So we're quite confident that for the monitoring point of view, we can produce this multi type of monitoring that includes from individual sensors to drone-based sensors, so from different scales and different perspectives.
That would be fantastic to see the results, from that. And how long do you plan to monitor for?
So we plan to monitor for the whole duration of the project. So the project will start October next year, and we plan to do the monitoring from October 2025 to 2028. But we are lucky enough that some of these sites, we have already been monitoring them for other projects. So we can try and correlate the data that we already have with the observations that we will have with the project. So the idea is that, especially for Holnicott, because we've been monitoring from the very beginning, so from last year, that hopefully we will have more than 3 years of data available for that.
That will be a fantastic data set to explore and to demonstrate, these projects. And we have some time for questions now. You should be able to unmute yourself, or you can raise your hand or pop a comment in the chat. Is it Lawrence? I'll go to you first.
Hi there. Thank you very much. A really interesting talk. I was wondering if you could say what your sites are up in Scotland and where they are. They look like they're up in the Cairngorms, maybe. Are they up from river sites, or are they more typically heavily modified sites down towards the bottom of catchments?
So they are indeed in the Cairngorms. We're going to have the Dee, the Fesci, and the Tromi. So we have a mix of sites that are natural, but we have also a mix of sites that have been quite heavily modified.
Okay. When you say the Dee, that's a huge river. Is it a particular part of it, or is it tied into kind of a wider scale monitoring?
Just a section of the Dee. That's SEPA. They're planning to do some restoration with largewood, and I think they actually implemented them now. So we're planning to do monitoring that specific intervention area. Okay.
Do you know what catchments they are by any chance?
Can't remember on top of my head. They're actually quite nearby. The Dee is near the Fesci one, I think.
Okay. That's interesting. Thanks very much.
No problem.
Richard.
Oh yeah, thanks for the talk, Diego. Very interesting. I just wondered, given that you've worked over in Devon, I just wonder whether there's any risk with beavers. I'm thinking of the sort of River Otter, for example. Obviously, they're restoring rivers themselves and taking trees down. Is there any need for sort of human intervention with pinning trees that have been taken down by beavers, or have we found over there that the trees that they've taken down tend to sort of be retained within their wetlands they've created. I just wonder, in terms of risk to bridge collapse and things like that, is there any human intervention needed in that side of things?
Yeah, and quite interestingly, in Crewe, this research centre in Exeter, we actually work with beavers. We've been monitoring beaver sites and the effects that they've been doing. Personally, not myself, but at least 3 of my colleagues are working on that. Interestingly enough, when beaver they fell trees, they tend to remain in the area, because what they create, beavers, is they normally do that in small watercourses, so they're less likely to have large transport of wood. It may happen though, and it does happen around the beaver pond, meaning that it's an area in which the flow velocity are normally quite reduced, so it's unlikely that you will see these trees being transported and removed. It may happen, but I would say it's much more likely that you will get it from bank erosion than from beaver activity.
Right, thank you.
No problem.
Martin, you've got your hand up. Martin, you are on mute if you're speaking.
Am I live now? Yes, I think
There we
so.
go, can hear you now.
Okay,
Yeah.
so Diego, you in your summary slide, you sort of say that large wood has historically been seen as a hazard. In many rural communities, large wood would still be seen as a hazard, and there is very vocal support for, let us call the engineering solutions to flooding, which would require removal of large wood, removal of riparian woodland, and dredging. How do you think, as people advocating river restoration, do we counter those views?
Yeah, that's a crucial question, and actually one of the key issues in implementing these river restorations, which is also true for like beavers and anything else. The problem that I can see based on my experience is that engagement with the local community sometimes hasn't really been efficient. I.e., what is missing is that the local communities, they like to have their voice heard. We have some examples on the River Otter, indeed, in which there was a restoration being done a couple of years ago, on the River Otter, and the local community was vocally against it. What changed the perspective there was that there was a totally different approach in which the local communities started having an interaction with us as academics, with the project team, with the designing team, and with the modeling team. The key issue is that people don't feel heard, and even if you try to explain things, they see more as a top-down approach. They like to be involved in the design and development process. So if you start having these stakeholders, this local population, being involved in the process of designing and deciding where restoration can be placed, the perception changes and may change quite significantly. So this is something that definitely needs to be investigated further. We do actually have a PhD going out next week for advertisement, in which we want someone working on that specific topic.
Thank you.
Thank you.
Okay. Any more questions? Everyone's quiet. Okay, well, Diego, you're happy for people to contact you, aren't you, afterwards if they have any further questions? Brilliant.
Absolutely, yeah, please do.
Brilliant. Oh, we've got one hand up. Michael.
Thank you. Yeah, Michael Green, Environment Agency. Yeah, so I just wanted to ask Diego if you could share the references that you referred to in your PowerPoint. I'm not sure if they were the full references at the end of the presentation, but yeah, it will be useful to, particularly those referring to the 30% bridge failure and increase in scale depth, because I think it would be something that would be useful to reference in future.
Absolutely, yeah, I can reference those to you if you want. I can send them directly. I can also send the documents that are now adopting the papers that we've been using. For example, the National Highways one, that's freely available, so it can be downloaded. But I'm just happy to share that.
Yeah, that would be great. Thank you very much.
Yeah, no problem at all.